Let me tell you a story. It's the Greek myth of Icarus, son of the brilliant inventor Daedalus. To escape a labyrinth, he and his father donned a set of wings to fly from Crete to the mainland. As they soared over the sea, ignoring his father's warnings, Icarus flew too close to the sun, melted the wax in his wings, and plummeted to his death. They say he was too proud and too headstrong, but I don't think he was. Icarus was a test pilot, the first human to ever set an altitude record, and the first ever to push his craft to the limit. So what does humanity learn from his sacrifice? Apparently not so much. When the Hubble Space Telescope launched in 1990, it had its own set of wings, those flexible solar panels, and it soon found it couldn't control them either. The sudden appearance of the sun on orbit rapidly heated one side of the panels, flexing them back and forth, and shaking the entire spacecraft so hard it couldn't perform deep field measurements. Hubble was flapping like a bird, and engineers couldn't figure out why. The solution they came up with was to give Hubble a set of rigid solar panels. In other words, to clip its wings into a set of hard stubs. That's no way to explore space. We need bigger solar panels, more antenna area, and we can only do that if we can stretch these spacecraft wings as wide as we can. That's where my research comes in. My lab makes these spacecraft wings, and my job is to make sure they don't fail in sunlight. By predicting and measuring how much these structures will bend and twist in sunlight, we can design better panels and antennae, ones that soar instead of flap, and ones that stretch instead of sag. Now, just like Icarus and his dad, my approach lies half in theory and half in experiment. My simulations in the computer model wings we haven't even built yet, while my experiments on smaller wings prove that we can trust this model's results. Because this simulation is a bit tricky. How much a structure bends will affect its heating, but its heating will determine how much it bends. So you have to model both effects at the same time. Now, if these predictions aren't enough, because even Daedalus had the right predictions, we can model the wings themselves to not be as affected by sunlight in two main ways. The first is to make the wing so thermally conductive that the entire wing heats, not just one side, which makes the wing evenly stretch instead of bend. The second is to carefully paint the wing, adjusting how much light is absorbed and where to reduce uneven heating. It's been 4,000 years. It is time to one-up Daedalus and his heat-sensitive wings. My hope and dream is to give spacefarers these longer and larger panels to stretch their wings as wide as they can dream, and far from just matching Icarus, to fly even higher than the sun, to soar on to the stars. Thank you.